So let's start with an overview. To give an overview how neural networks works in Supervisely, I will need two projects. One image project and the other is video project. But let's move step by step. So first, let's take a look at how web browser and GPU resources necessary to train models are interconnected. So we want to stay inside web browser and still be able to use GPU cards, machines with GPU to train or to run inference of deep learning models. And if we go to Supervisely cluster team cluster page, we will see that we have some machines connected to my account here. So, for example, here is one machine that is connected. So we can see NVIDIA SMI for this machine, and there is probably another machine that might be connected also. So let me find the one. So for example, this RTX machine is also connected to Supervisely, and whenever I want to initiate some, say, training procedure or inference procedure that is required, for which GPU resources are needed, I can pick which machine to use for that purpose. And moreover, we can add as many machines as we needed. So if I click Add button here, I will see a command that I can execute on any machine with GPU that has Docker and NVIDIA Docker installed. And as a result of running this command on a machine with GPU, Python agent, open source Python agent will be installed on that machine, and after that the machine will be available in running status, like these two machines, for example. So let's move on. Essentially, when we work with neural networks in Supervisely, we work with apps. So there are different categories of apps in Supervisely, and some category of apps is related to neural networks, which and these apps usually allows us to deploy models or to train models. So those apps are nicely summarized in neural network page here. So, for example, for various modalities that we support, say images, videos, point clouds, DICOM, we may define a set of tasks which we can address with Supervisely. So, for example, for object detection, we have apps that allows us to train detection models based on YOLO v5 repository and MM detection repository, and also the models. And also the app that allows us to deploy models from these repositories. So probably the first thing to note here is that for each, we have a pair here. So for example, we have an app Surf YOLO v5, which allows us to deploy models from this repository, and also train YOLO v5, the app that allows us to train the models. The same for MM detection. And if we just keep going and considering different tasks that you can solve with Supervisely, you will see, say, if we take semantic segmentation, there will be also a pair of apps, MM segmentation and Surf MM segmentation and Train MM segmentation. We support instance segmentation as well, classification, interactive segmentation, metric learning a bit. For videos, we might have another set of tasks, for example, detection and tracking. And the nice thing about that is that models that work for images might be also utilized to process videos. So there is also segmentation and tracking apps here. So you can play with that and see the full list of models that we support. But I think that the overview will be not as complete if I just don't run several apps and show you how it works in real time. And in this overview, I will just focus on inference procedure. So suppose that we already have some models, and those apps and corresponding repositories provide a number of pre-trained models that we can leverage straight away. And briefly, we can further decompose the models, the neural networks that we support, into like two categories. The first category is more like standard models, say detection models, semantic segmentation models, instance segmentation models, and the other category is interactive models. For example, interactive segmentation, when the model architectures are designed in a way so that the models can interact with the user to speed up labeling process. So let me actually run first object detection model here. So I will use MM detection app here, serving app. So for example, if I run this app, I might specify which machine I would like to use to run this app. So I will pick this machine and just run this app. So once the app is started, I can pick the task. So this MM detection framework supports two types of tasks: object detection and instance segmentation. Let me pick object detection here. And then I can see pre-trained models available. So MM detection is very powerful repository, and it contains quite a number of pre-trained models that we can actually run and also which we can train. So for example, we can pick different architectures and see corresponding checkpoints for those architectures with some information. So let me actually pick, say, the first one, the first architecture here, and I will just pick the model with the highest accuracy on Coco dataset, this one. Maybe it's not the fastest model, but it should be accurate. And then I will deploy this model. So for that I need just to click Serve button. So now the model is deployed on the machine that I picked beforehand, before I run this app. So let's actually proceed and deploy several more models, but this time I will deploy interactive models that interact with the user. So just again, I do this just for illustration purposes. And one model that I will use is RITM model for interactive segmentation. So I can also pick a model here and pick the machine which I would like to use to deploy this model. So let me pick again this machine. I'll run this app. And finally, I will deploy yet another model, yet another interactive model that actually allows me to track objects on video. So let me actually deploy this one as well. And I will also use the same machine. So I have deployed 3 models on the same machine here. So let me deploy the model. Now I have all the models deployed. Let me go to probably app session page and click on Running tab here, just to illustrate that I have one model deployed from MM detection app and model for interactive segmentation, as well as taken model. I will first work with the detection model. So if I go to my current workspace and to projects, let's first apply this model to process this project with just 5 images. And the typical scenario when we want to do that is when we want to pre-label. So the beautiful thing about neural networks in Supervisely is that once we deploy the model, we might use various inference interfaces to interact with the model. So for example, I may I will run an app called Apply Neural Network to Image project here. This one might be run. This app does not require GPU, so I will run it on the machine without GPU. So the application is started and I can open it. And the first step that I do, I connect to the model that I have just deployed. So I connect to the model. And this model was pre-trained on Coco, so there are a number of classes that this model might recognize, and I will pick all of those. I can pick different classes, but let me pick all of these classes. And then I may say, okay, let this model to be applied to the entire image. I may define some parameters here, for example, confidence levels, and I will also see the preview, so how this model is working. So this app also allows me to see preview. I may do preview on random images here, or on some specified image that I may pick. So if I run this, so this is the default name of the project that will be created as a result of the execution of this app. So let me actually click apply model to input data, so that this new project is generated, which will contain the original images plus all the recognitions, all the detections. So let me click here, and almost instantly we get a new project. So the app is completed. App solves the task, so it processes the images, and here is the project that was automatically generated. I can click right here to go to this project, or I can go back and see that there is a new project now. And if I open this project, I should see the result of the processing. So what we see here, we see that traffic lights are recognized here. We also see that we also can see that persons are recognized here in a correct way. We might also see other classes. The colors might be not that good. We can always change the colors, but we see that even plant class is correctly recognized. And we can keep going and see here that also all the persons are recognized, as well as very small objects here. So, this is how easy it is to pre-label the images. And of course, this is toy example in my case. I have just 5 images. In real world scenario, you might have thousands of images, and to pre-label them in this kind of way might speed up labeling process. So let me go further actually. And go back to the projects. And this time, what I would like you to demonstrate is that once I deploy this detection model, I can also automatically process not only images but also videos. So I have a video here. So let me actually probably play this video so that you understand what we're trying to recognize here. Turn off the sound. What we try to what data we try to process. So the video is like this, and maybe what we are interested in is to detect every car here, and moreover, maybe it's also important for us not only to detect but actually to track each car, so that we know that this car is the same car on the next frames. And that is actually pretty easy to achieve, this kind of pre-processing with Supervisely. So if what I just need, I just need another app, another inference interface, which will use the same deployed model, and to do that I can run the corresponding app here. Since this model will also do solve taking task, we need a GPU for that. So I will say that please run this app on this GPU one more time. So let me run the app. So the app is started and I can open it. So I have a project with one video. I will select this, and then the procedure is very similar. So I connect to the model that I have deployed earlier. Again, the same classes. I will probably just, for simplicity, pick all of them. Yeah, I select the classes. Then I may also specify some confidence levels and the name of the output project. So let me call it, say, let me call this project video pre-labeled. Okay, so and I can also click a preview button to see what kind of results I might expect when I apply this model to the entire set of videos that I have. So it might take a bit of time to generate this preview, and that's convenient because we might want to play with the confidence levels before we apply the model to the large amount of long videos. So here we see the preview. We can actually play this video, and we see that actually the results are quite good. Probably I shouldn't change anything here. So I will just apply the settings, and then after I click this button, apply neural network to video project, what will happen is that there will be another project will be created under this name, which will contain the source videos as well as automatically generated boxes. So let's actually apply this model to the video. It might take some time for the model to process this video, so let's wait a bit. So now every frame is processed, and now we apply deep sort to merge detections together to obtain tracklets. And finally, we get this new project. Again, I can click here, right here, but probably I just like to show you that that we just have here a new project, and if I open it, we should see the results. And okay, let me turn off the sound here. So what we see is this, not only that the cars are detected here, but the cars are actually, the identification or task is solved, or taking task is solved, so that, for example, we know that this car exists on multiple locations here. So that was a demonstration of like standard models. You can expect the similar behavior with of models, of semantic segmentation models or instance segmentation models. But let me actually show you interactive models. I have deployed a couple of those, and I may actually show how they work. So I will just drop everything here. And sometimes I might not have the ability to like pre-label. Maybe the classes of interest are rare and not that common. So there are other ways to leverage deep learning models to speed up labeling process. So in this case, I will quickly demonstrate the tracking model that I have deployed earlier. So I just label here several cars, and what I might want to do is to propagate these bounding boxes further. So And the way to do that is to rely on the model that we have on the app and on the model that we have deployed, so it's called trans-T, and it will propagate either forward or backward the annotations that I created here. So the way it works is like this. So what we see here is that so this icons indicate that we manually labeled this frame, and if I go to the next frame, I see that the boxes are propagated further. So that I may correct them and propagate again. But this is an example how we can use interactive models in order to label the data. And last model that I have deployed was the smart tool, and let me actually also show how it works. So I'll just go and to this original project with 5 images. So maybe I will just pick some image here, say this one, and what I can do, I can pick this smart tool and say I will define a person class if I want to label person, and I will localize this person, and this model will try to guess the masks for the object of interest, so I can provide another feedback, and you see that we obtained quite a good result here. So this is another illustration of how we could use pre-trained models to speed up labeling process. And these models are kind of class agnostic, so let me try to find, say, some. Maybe we're just interested in segmenting the head like this, and but probably I have to. I don't have to say that this head is person, so the proper way to do that is like to say, okay, I need to create another class. Probably I call this class head, and I can use these default models, default pre-trained models to help me to help me to label these common objects. So like this. Okay, so now so far I have been showing to you how to leverage different pre-trained models, either standard models or interactive models. But what I would like to do actually is to showcase the scenarios when default models are not working for some reason, and we need to train models. And you will see in the next section how simple is that to achieve that.